Sample exercise 16.9 is all about how to use the concentration of a strong base to find the pH of that solution. So let's walk through the sample, just make sure that the steps make sense. Our question is determining pH of two different solutions. The first, you have a 0.28 molar sodium hydroxide. The second that we have is a 0.0011 molar solution of calcium hydroxide. The big thing to notice is that we have two hydroxide ions that would form based on this. So that means we're going to have to take the concentration and double it when we're trying to find the hydroxide concentration. Now that we've analyzed the problem, the plan is essentially there are two alternate methods that we can take. The first method that you can think about is using the molarity of our original either sodium hydroxide or calcium hydroxide, take our molarity of our base, convert the molarity of base into the molarity of hydroxide ions, and that's going to be in a 1-to-1 or 1-to-2 ratio. Once we have the molarity of our base, we can then deviate in two different directions. Go from the concentration of hydroxide to the concentration of our hydrogen ion, then into pH. Alternatively, we can take method 2. Concentration of the hydroxide ion can be taken into POH, then from POH into pH. Both methods are being presented here, but I'm going to strongly suggest that you follow the second method. Anytime you're able to do the POH to pH connection, it's going to be much simpler in terms of the calculation than going from a concentration to a concentration. So as I work this out, once again, look here at method 2. I'll do the calculation so you can follow. Our original concentration of sodium hydroxide was 0.028 molar. So that's 0.028. I'll put it in the calculator. We're going to take the logarithm and then negate that. And you get 1.5528 as our answer on that first part. Now that I've got it, I'm going to round that just to 2 past the decimal. Then we take our 14 minus that 1.55. And we end up with 12.45, which is the answer is given here. In the second situation, we're using calcium hydroxide. So remember, you're going to have to double the original molecular concentration. And we're going to start with 0.022 molar hydroxide ions to begin. Now I will again say please follow the method that allows you to do the least complicated math. Go POH to pH. Here we have POH is negative log of 0.0022. Doing that here in my calculator, I plug in 0.0022. Log and negate, and you get 2.6575. Rounding that back, you get 2.66. So 14 minus 2.66 going to get us 11.34, which is our answer to that. Now let's do our first practice exercise. Here you'll notice we have a multiple choice, which we're going to treat just like we would on the AP exam. The question is asking for us to order the following 3 solutions from smallest to largest pH. Recall that when it comes to hydroxide concentrations, if you have a large concentration of hydroxide, that means you're going to have a high pH value. So a lot of hydroxide ions means high pH. As you look at it, see that we have barium hydroxide, potassium hydroxide, and pure water. So we know right off the bat that pure water is going to have a balance of our hydrogen and hydroxide concentration. That's going to be on the order of 1 times 10 to the negative 7 as our molarity of hydroxide. That's going to be a very, very low concentration, relatively speaking, since the other two are strong bases. Next thing to consider is which one has more hydroxide, a 0.04 molar KOH or a 0.03 molar barium hydroxide. Well, since we have 2 hydroxide ions in barium hydroxide, we must double the concentration here, and it becomes 0.060 molar hydroxide concentration. So the largest concentration is in 1, the smallest is in 3. Our order is 3, then 2, then 1. And that's what we see here in E, 3, then 2, then 1. Now, the next problem here, bring that down for us, give us a little white room. So here we have our question asking what is the concentration of these two solutions. The first is a potassium hydroxide with pH 11.89, and then calcium hydroxide with pH 11.68. I'm going to do the same method that we had before for our part A. Our plan of action is going to be to use the pH to go to a POH. Then from POH, we can work our way to hydroxide concentration. And from hydroxide concentration, we go to the concentration of the original base, potassium hydroxide. So in terms of steps, pH to POH, remember that we're going to take the starting pH and subtract away the number from 14 to get to POH. So 14 minus 11.89 is going to get me POH. I get 2.11. Now, to get into hydroxide, what we do is 10 to the negative POH in order to find hydroxide. So our POH 211 is there, we negate that, and then the 10 to a power button. So that's 0.007762. I'm going to just take that as 0.007 and 77625. I'm going to take a lot of digits because I don't want to round until the very end. Now, since this is a 1-to-1 ratio of hydroxide to potassium hydroxide, this molarity of hydroxide is equivalent to the same number of potassium hydroxide. And I'm going to just shift this into scientific notation now and round it off to 2 sig figs based on our original 2. That becomes 7.8 times 10 to the negative third molar potassium hydroxide. For our final problem, it's going to be the same essential set of steps, one small difference, and that is that it'll be in a 2-to-1 ratio in the end. So I begin 14, take away the 11.68, and that is going to get us to our POH, 2.32 at the POH, 10 to the negative 2.32 as we did before. This time I have 0.004783 molar hydroxide concentration. Now there are 2 moles of hydroxide for every 1 mole of our calcium hydroxide. So this time I divide by 2 in order to do this conversion. So take your answer there, divide by 2, and I should have 0.00239. I'm going to round that off and put it in scientific notation. 2.4 times 10 to the negative third molar calcium hydroxide.